For the first time in history, water quality is no longer measured only by utilities and laboratories. It is measured by homes. Each sensor inside each apartment becomes a data point. Alone, it protects one family. Together, they create a living map of an entire city's drinking water. This is crowdsourced water intelligence. Traditional water quality monitoring is based on fixed sampling points. These locations are limited. They cannot represent every street, every building, every hour of the day between two official samples. Water conditions can change many times. Crowdsourced monitoring fills these spatial and temporal gaps. It transforms isolated measurements into continuous coverage. When smart sensors are installed in homes, they create a distributed sensing network. This network has two unique properties. High spatial resolution, real-time temporal data. It detects local variations that would otherwise remain invisible. A pressure drop in one district. A disinfectant decay in a single building. A taste and odor event in one neighborhood. Urban water quality becomes visible in real time. For crowdsourced systems to work, privacy must be protected. Individual data is anonymized, aggregated, encrypted. What appears on the city map is not a home, it is a condition. This allows communities to benefit from shared knowledge without exposing personal information. Trust is built into the system architecture because the network is continuous. Anomalies appear as patterns. A contamination event does not remain isolated. It creates a spatial signal. Utilities can detect disinfectant loss pipe, corrosion zones, stagnation areas hours or even days earlier than with traditional monitoring. Response becomes proactive. Crowdsourced monitoring transforms citizens into active participants in water management. People no longer ask, "Is my water safe?" They ask, "How is our water system performing?" This creates awareness, accountability, community engagement. Water infrastructure becomes a shared responsibility. When residential monitoring connects with utilities, a new operational model emerges. Utilities receive real-time demand data, real-time quality data, real-time anomaly alerts. This allows dynamic network management, targeted flushing, optimized disinfectant. Dosing. The distribution system becomes adaptive. Crowdsourced monitoring is not limited to one city. With standardized platforms, data can be shared globally. This allows comparison between regions, early detection of emerging contaminants, rapid response to large-scale events. Drinking water becomes part of a planetary data system. When every home measures water, every city understands it. The implications of this shift are profound. It democratizes data, empowering individuals and communities with the knowledge to advocate for better infrastructure and policies. This citizen-led approach fosters a new level of transparency, holding service providers accountable and driving improvements in water management practices across the board. Furthermore, the vast data sets generated by these networks fuel innovation. Machine learning algorithms can analyze the data to predict potential issues. optimize water treatment processes, and even identify long-term trends in water quality that might be linked to environmental changes. This predictive capability is a game changer, moving us from a reactive to a proactive stance on water safety. The economic benefits are also significant. By pinpointing problems with greater accuracy, utilities can allocate resources more efficiently, reducing waste and operational costs. This can lead to more affordable water services for consumers and free up public funds for other essential services. Ultimately, a global network of crowdsourced water intelligence could revolutionize our relationship with this vital resource, ensuring that safe, clean drinking water is a reality for everyone, everywhere.